Let's look at matrix transformations for GCSE further maths. I have made another video on matrices in general, so I'd recommend you watch that one first if you haven't already. Example 1. The matrix 3x 6 minus 3 maps the point y4 onto the point minus 14, 24. Find the values of x and y. For this question, we want to multiply 3x 6 minus 3 by the point y4 and say that that's equal to the image of that point, so minus 14, 24. When we multiply these two matrices together, we get this. 3y plus 4x, 6y minus 12. And if you're not sure how I did that, just go back and check out my previous matrices video. That's equal to minus 14, 24. And from here, we just need to solve some equations. Let's start with 6y minus 12 has got to be equal to 24. When we solve that, we get this. 6y equals 36, therefore y is 6. Next, we can look at the top line. 3y plus 4x is equal to negative 14. Now that we know what y is, we can just pop that in. So 3 times 6 plus 4x equals negative 14, means this. And therefore, when you rearrange, you get x is negative 8. Example 2. The point 4a is invariant when transformed by that matrix. Find the value of a. If a point is invariant, that means it does not change during a transformation. Because the point is invariant, we can say that when we multiply the matrix by it, it will stay the same. If we multiply the two matrices that are on the left, we get this. Minus 20 minus 2a, 12 plus 2a, and that equals 4a. Now we can solve this equation. Minus 20 minus 2a is equal to 4. When we solve that, we get this. So a is negative 12. We could use the second equation to check our answer. So 12 plus 2a is equal to a. Let's check if that's true. 12 plus 2 times negative 12 is in fact negative 12. So that means we've done it right. Example 3. Describe fully the single transformation represented by this matrix. There are different ways of doing this. My preferred way is to think about what would happen to two specific points under this matrix transformation. Those two specific points are 1, 0 and 0, 1. So I always draw a sketch and then think about what would happen under this matrix transformation. Starting with this matrix 1, 0, 0, 1 to represent those 2 points. According to that matrix, these 2 points will go to 0, minus 1 and 1, 0. So 1, 0, this point, ends up going to 0, minus 1. If we put that on the sketch, that goes down here. Now let's consider 0, 1. That goes to 1, 0. So 0, 1 goes to 1, 0. Looking at our sketch then, that looks like the points have rotated around, which means the answer to this question is that the transformation is a rotation 90 degrees clockwise about the origin. Last example. Here are two transformations, A and B. Work out the single matrix which represents the combined transformation A followed by B. Our transformation A followed by B, that's important because order matters. In fact, when we have multiple transformations, if we think about a point to start with, x, y, we're going to do matrix A followed by matrix B in this order. So you work right to left. That way, matrix A gets applied to x, y first, followed by B. For this question, we're given the transformations as descriptions, so we need to actually work out the matrices first. Again, I would use a sketch to help me with this. And on that sketch, I'm going to consider those 2 points, 1, 0, 0, 1. When I put these in a matrix, it looks like this. I want to figure out the new matrix under the transformation. This will tell us what matrix A is. Let's start with 1, 0. If we're rotating 180 degrees, that's going to end up over here at the point minus 1, 0. So we can fill that in there. That's gone all the way around. I'm just going to do clockwise here, but it doesn't matter for 180 degrees. You can go clockwise or anti-clockwise. Next, let's think about what happens to the point 0, 1. If we follow that rotation 180 degrees clockwise, it's going to end up down there. Point 0, minus 1. So you can put that there. And now we have our matrix A. Let's do something similar for B, starting with these points, 1, 0, 0, 1. Put them in a matrix, 1, 0, 0, 1. And let's think about what matrix B is going to be. We start with this point, 1, 0, and we reflect in the x-axis. That's not going to change, so that point is invariant. It will stay the same as 1, 0. Point 0, 1 will change. It will reflect down and go down there, become 0, minus 1. so that can go there. Now we have both of our matrices, we can apply them in the correct order. As we saw earlier, it will be BA. Let's multiply them together. 1, 0, 0 minus 1, followed by minus 1, 0, 0 minus 1. When you multiply those together, you get minus 1, 0, 0, 1. And that's the final answer. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.